In this lecture, we shall discuss about the next test, that is the Cauchy root test. If sigma un is a positive term series such that limit of un raised to 1 by n as n tends to infinity is equal to k, then if k is less than 1, the series converges. If k is greater than 1, the series diverges. That means we are going to take the nth root of the nth term, then take the limit as n tends to infinity. And the comparison is with 1, the same comparison as we have in DL inverse ratio test. That is, if k is less than 1, the series converges. If k is greater than 1, the series diverges. Then for k is equal to 1, the Cauchy root test fails. Then we go back to the simple test what we have mentioned whenever k is equal to 1. Examine the convergence of the series sigma 1 divided by 1 plus 1 by n raised to 1 n square. I have named the series as sigma un, considered the nth term as 1 divided by 1 plus 1 by n raised to n square. We take the nth root of this nth term, so it becomes 1 divided by 1 plus 1 by n square by n becomes n. We apply the limit as n tends to infinity, and already we know this result, 1 plus 1 by n raised to n as n tends to infinity is e. So we have the value as 1 by e. So 1 by e is less than 1. So as per Cauchy root test, sigma un converges. Now you can also try this example which I mentioned here. Check for sigma n equal to 1 to infinity 1 plus 1 by n raised to n square. Check the convergence or divergence for this positive term series. The next example, test the following series for convergence. Sigma n equal to 1 to infinity n plus 1 raised to n x raised to n divided by n raised to n plus 1. I've named the series as sigma un. Then I've directly taken the nth root of the nth term. So those powers n will get cancelled. So a numerator will be n plus 1 into x. Denominator is n raised to, the simplified form of that power will be 1 plus 1 by n. Now those n terms in that part what I have marked, I have taken that term together, n plus 1 by n. Then we have x in the numerator, n raised to 1 by n is another term. So the term inside that red marking is written as 1 plus 1 by n, x divided by n raised to 1 by n. Now we apply the limit as n tends to infinity on both sides. 1 plus 1 by n reduces to 1. We have x in the numerator. Denominator limit as n tends to infinity of n raised to 1 by n will be 1. This you can try by this indeterminate form of evaluating the limits. So n raised to 1 by n will be the indeterminate form, infinity raised to 0. So you can just work out separately and check. How do you work out? You take log of both sides, then convert it to infinity into 0 form, then convert it to 0 by 0 form, and then evaluate. You'll find the value as equal to 1. This part you can just try and see on your own. You'll have already studied that indeterminate evaluation of limits. So since we have got it as x, sigma un converges if x is less than 1 and diverges if x is greater than 1. This is done by Cauchy root test. Cauchy root test fails for x is equal to 1. So we take x equal to 1 in that sigma un, and un is rewritten as n plus 1 raised to n divided by n raised to n plus 1. Now we simplify it in this form. Now for this example, when we go for this case, you either have to choose sigma vn, this is 1, or else you'll have to go for Cauchy's fundamental test. Now here check whether you can go for sigma un. If you simplify this, we get it as 1 plus 1 by n raised to n into 1 by n. Of course, you can choose Vn here. Choose sigma Vn is equal to sigma 1 by n. And now we all know the next part, what is to be done. It is the comparison test. Okay. By comparison test, what do we write? Limit of un divided by Vn. You'll find that value as equal to some finite value. You have to work those steps. Then we say sigma un, sigma Vn both converge or diverge together. Then on observation, we find sigma Vn is a p series where p is equal to 1. Then by p series test, sigma Vn diverges. Then by comparison test, sigma un also diverges. And finally, you have to write down the result. It becomes sigma un converges if x is less than 1 and diverges if x is greater than or equal to 1. So conclusion, you have to write it again. Write down the result.